So the definition of a logarithm is it is the inverse of an exponential function. And so what it does is it helps us solve for x in an exponent when we haven't been able to do that yet because we haven't had an inverse. So what we think about is if we have, and I'm going to use the same, well, I'm going to use the same letters. I'm going to change the letters actually. I'm going to use x and y. If you have b to the x equals y, that's an exponential function. And I used b because that's the base, x for the exponent, and y is what it's equal to. It's the same as if you wanted to write this as a logarithm. The definition of a logarithm says that you have log of base b of y equals x. So we can interchange an exponential function with a logarithmic function. And what a logarithmic function does is the whole purpose of a logarithmic function is to help us solve for an exponent. So when you're writing it in log form, you say, well, a log solves for an exponent, so that's why the exponent is over here. The base of your exponential goes with the base of your log, so that's easy to remember. And so if you remember that logs solve for exponents, that your exponent goes here, then your answer, which is what I often call the y, because that's the answer to your exponential function, your answer goes inside of the logarithm. And this is the definition of a logarithm. And we're going to use this definition quite a bit. We're going to take some things in exponential form and write them in logarithmic form. We're going to take things in logarithmic form and write them in exponential form. And that's what we're going to do in example 1. So here we are in example 1, part A. Write each exponential expression as a logarithmic expression. So it's just using the definition. So definition here, 3 cubed is 27. So we want to write this as a log. Well, the base is the same as the base. Logs solve for exponents, so the exponent is going to go over here. And the answer is going to go over there. So log 3 of 27, and that's how we read it. Sometimes people say log base 3 of 27. And eventually you can get rid of that base word if you want to just say log 3 of 27 is equal to 3. Now mental math-wise, this is going to take you a little while. Because if I say 3 cubed, you probably think of 27 quite quickly, right? But if I say log 3 of 27, that is totally new and looks different, and it's going to take you a while to figure that out. And so what you're going to have to say to yourself is, if I was trying to figure this out, okay, log 3 of 27, basically the way I look at it is I know that the base is 3, and logs solve for exponents. So I put a little question mark in here in my head, and I say log 3 of 27 is basically saying 3 to what power is 27? And then you'd say, oh, 3 to the 3 is 27, so log base 3 of 27 would be 3. And so I think this little question mark in there, when you see a log and sort of say, make me think of it as an exponential function. Logs solve for exponents. So I'm really saying 3 to what power is 27? That's what log 3 of 27 is asking. So if we're changing the other ones, here's part 2. The base is 5. The exponent is -2. And in here we have 1 over 25. And in part 3, 4 to the 0 equals 1. So log base 4 of 1 is equal to 0. So some things about writing this down as far as how do you write this in your note. The word log is just like the word log you would write on a line. Normal, like here's your lines, you would write This feels like grade 1, where you write, should I have the dotted line in here in the middle? You remember that? How you used to write and make sure some things didn't get too big. So you'd write log normally. The 4 is a subscript, so it's smaller and it's written lower. And then the 1 inside is just like a normal 1. And your answer is just like a normal answer. So when you're writing it in your notes, that 4 is a subscript. Oh, does this bring back good memories? You're like grade 1? No? Those 2 years of grade 1 were not fun? Okay, shoot. Okay, part B. We want to write each of these logs as an exponential expression. So again, we look at it, log 7 of 49 is 2. So 7 is your base. The 2 is your exponent, and 49 is your answer. Which, if you think of it, when I see log 7 of 49, and if I put that tiny little question mark in there, we'll pretend that's a question mark. 7 to what power is 49? The answer should be 2. This one's a little bit harder. 4 to what power is 1/64th? Well, if I change that to exponential form, the base is 4, the exponent is -3. And 4 to the -3, if we remember our negative exponent laws, that makes sense that that's 1/64. And in the third one, 10 to what power is 1/10,000? So the base is 10, the exponent is -4, and we get 1/10,000. Okay, practice some definition of a logarithm right now, 5, 6, and 8.